manually set it.
But then that wasn't helpful.
It wasn't helpful.
All right, so let's go ahead and get started. After we finish chapter 4, we're going to shift gear and talk more about software development, because that's also a major part of this class, is to talk about software development. Basically, how do people design software, and how to write simple software. For people who want to get a head start, I can tell you exactly where to go, because you want to go to scratch.mit.edu. I showed you guys once already, I think.
Yeah.
And this is what we'll be using for the programming part, because I don't want to bore you guys with actual programming languages where you have to deal with the syntax and all the other stuff. This is all drag and drop. It's really literally just drag and drop. And you can produce programs and publish it too. This website itself, scratch.mit.edu, it's kind of like YouTube, but for programs like this. You can publish your games if you want to, so other people can play the games that you have designed. You can easily integrate graphical design and also audio, sound effects and whatnot into your games or into your program. You can turn it into a presentation. You can make it a very interesting presentation using this type of program. The resolution is not good, okay? Let me warn you ahead of time that you're not going to get super high resolution, but it's very programmable and easy to program too, very easy to specify the logic that you want to specify. It is available for just about any platform. When you click the download link, you can see that it's available for macOS 10, Windows, and also for Debian distributions. So it makes it really kind of handy. What I will do today is I'll just kind of show you guys what you can do with this so that you guys can download it and play with it a little bit. There are tons of YouTube clips on Scratch already. In other words, people have written, produced tutorial for this particular product and published those things on YouTube already. So you can just look up YouTube Scratch programming and you can find lots of tutorial. But I'll just go ahead and show you some really basic features of this, and then we'll continue with the operating system discussion. All right, so we got the program downloaded, and now I have to install it. But I forgot where it's downloaded to, so I have to look it up. It's under downloads. Of the package is Scratch something. There we go. I have older versions here too. So we'll try the latest version, which is with the 0.6. This is how I install software in Debian Linux, and it's complaining because I don't have the other packages installed. So recording. Yeah, I started the recording already. So this is also a good demonstration of the differences between Windows and Debian Linux, because if I know that I have certain dependencies missing, I can actually just go ahead and install the other ones too. So in this case, I have squeak-vm, squeak-plugins-scratch, and lib GTK2.0-vm. Some of those may not be available. We'll see. Oh, we found all of those.
Is it faster to download through the command prompt than it would be to go through the website?
It's just a whole. To me, this is a lot faster because I know the commands already.
Download speed, is there any difference?
No, there's no difference in terms of download speed. Okay, I just set up the software, and that's how easy it is to set up the software. But one thing you might have noticed is I am no longer user. I'm now root. In other words, to install any type of software, I have to change to the administrative account. I cannot just use an end user account to install software. And typically, after I install software, I will switch back to my regular user account. And that's just basic safety or security practice. You can do the same thing in Windows. In other words, set up one single account for installing software, for doing virus scan and defragging your hard drive, and use your regular user account just for browsing. But make sure that you limit the permissions of the regular user account. So in case you step on something suspicious, it's not going to cause a system-wide problem. It will just be limited to a user account. So now that it's installed, it should have installed something here, and I have Scratch installed here. Unfortunately, this will go away because I did not make that part persistent, so it would have forgotten about this installation the next time we meet on Tuesday. But this is good enough, I can show you what it looks like and what you can do with it. It doesn't look very interesting, does it? Yep.
Are you able to animate your own sprites?
Yes. In fact, that would be the first thing I can do is to animate the sprite, okay? This is called a sprite. This is actually the character called Scratch, and he is the main, he or she, we don't know the gender of the cat.
See the legs in front.
Yeah, it's always very strategically placed. But anyway, Scratch the cat is the kind of like a mascot of this particular program. So one thing we can do is, we can explore these tabs. These are basically tools that you can use in your scripting, in your program. So if you look under motion, I can spell this out because I think the font is a little bit small. This is move 10 steps. If you want to find out what that means, just click it. So if you click it, you can see the sprite just moved 10 pixels forward, like that. You can also turn it. You can see how you can turn the sprite and make it rotate. Now, after you turn, okay, let's say we turn it up like this, and then you move, it's actually moving in the direction it's heading. In other words, the sprite is not really just for display purposes. It actually has a direction. And when you walk, it is walking in that particular direction. You can also move in a counterclockwise fashion. You can make it go to a particular coordinate. In this case, it's x, y, and are both zeros. So when you click it, it just goes back to the center of the canvas. This is called, it's not the canvas, it's called the, there's a particular name for that, I cannot remember.
Stage.
Hmm?
Is it the stage?
The stage, exactly, it's called the stage. It's just like a production, it's the stage. The stage has its own program, it has its own scripts. Are there any questions at this point? So right now I'm using the sprite, as a remote control kind of thing, because I'm clicking everything to make it just do one little thing at a time. You can go to looks, okay, and you can switch the costume, so you can see. Well, let me point this one upside down, right side up first, so you can see the effect of that. So we'll point it back to the right direction, and then I can go to costume, and this one has only two costumes, so the animation is kind of crude. You can see how you can switch from one costume to the next, and if you just repeat doing that, it will look like the Scratch, the character is walking. But you can add additional costumes if you want. You're not limited only to 2 costumes, but it's only supplied with 2. You can make it say hello, which will pop up in this case, a speech bubble for exactly 2 seconds. Hello, and then 2 seconds, and then it disappears. Goodbye. You can also make a thought bubble, and it's just different looking, but it's basically the same thing. You can change its size. You can make it bigger or smaller. And with this, you can actually change the percentage right here. Let's say we switch it to 300% to make Scratch a lot bigger, like that. It's pixelated, so you can have the Ultraman effect if you want to make a character bigger and smaller. Yeah, how many people know what I'm talking about, Ultraman? Very few.
Rings a bell.
Rings a bell.
Rather than
All right, so we switch it back and then you click it. In other words, this is a really cool programming platform because you don't have to download expensive pay for tools. It is cross-platform. It doesn't matter which operating system you're using, and it's easy to experiment with individual actions. Okay, so right now it's just like a remote control toy. I'm remote controlling everything that it's doing. You can show, it is shown right now, so it doesn't really do anything. But you can also hide a sprite. In other words, you can make it quote unquote disappear, but it's still there. It is just not visible on the stage. When you have different sprites appearing on top of each other, you can control which one is overlapping which one. So which one is on top of which one. You can use go to front and go back, how many layers to control which one is on top. We can go to sounds. Okay, I think this may work, may or may not work. I'm not 100% sure, but you can make it play. So it works.
I thought it was a gag, yeah.
Could you guys hear that?
Yeah.
Okay, and you can change the sound. There's a whole lot of, well, I guess not a whole lot. You can also do recording. You can you record your own sound clip and attach it to the sprite, so you can make it hiss, for instance, for a cat. It's like, psst. Make a new costume for hissing. Halloween is coming up. You can make a black costume for a sprite. With a Halloween theme to it. That would be kind of cool. Play drum for 0.2 beats. Now this is new. I haven't played with this before. So we can. I don't know. Let's try double that. Oh, okay, that's the beat. So the lower the number, the slower the beat. And then you can also make this, this is the duration, so if you make this number bigger, there you go. Rest for 0.2 seconds. You can also make it play a note for half a second in this case. You can set the instrument to any type of these instruments.
Glockenspiel.
Which one? What number?
Number 10.
It's got to be
Number 10. Okay, we got that. Does it sound right?
No.
It's because they're not connected.
Yeah.
You gotta put them on the script or connect the two.
Oh, I think I forgot to click it first. So you have to click this first to set the instrument and then play the note. Oh, that didn't work either.
They have to be connected
Connected to.
on the script page.
Oh, okay.
Because otherwise they have nothing to do with each other.
Okay.
I believe.
These are all different steps. Okay, now this is the pen. You can ask a sprite to leave behind a trail. Okay, so it's kind of interesting because you can now use it to draw pictures. So right now I can say pen. So it has a pen attached already. You can only control whether the pen is up or down. So if I click pen down, that means the pen is now contacting the stage. And if I make the sprite move, it will leave behind a trail. You can see the blue line that it's leaving behind. Kind of like a snail or slug effect, right? You can also make the pen go up, which means it will stop drawing. You have control over the color that it's setting. You can also change the shade, size, and so on. And here are the stamps. I'm not sure what stamps are available in this case. You have, now this is the interesting part. The controls, that's the programming part. You can see some of these words. They have to do with how do we automate this sprite to do things without you having to click all the time and changing the settings. Okay, so we'll play with this a little bit later, but we'll go ahead and look at all the other tabs first. This is called sensing. In other words, the sprite is not really just a bitmap. It can actually sense its own quote-unquote surrounding. It can sense whether it is colliding with another sprite. It can sense whether it is touching a particular color. It can sense where your mouse is. It can sense whether it is being clicked on. So it has a lot of interesting things that it can sense. It can also ask you a question and wait. In other words, this is how you can type something as the input to the program. Okay, it can prompt you and say type something, and then it can take whatever you typed as the input and then process on that input. you can directly, it can know its own location. Okay, so it can know its own mouse. This is the mouse location, so it can detect the actual location of the mouse itself. It can detect whether the button of the mouse is clicked. So all the important elements to make a game out of this is already here. Okay, the only thing is, how do you make use of these features and connect everything together to make a, whatever game you want to do. You can go to operators. Now, operators is probably one of the least interesting and the most boring part of this entire thing, because operators do not work by themselves. They are basically ways to do calculations. Some of you probably cannot see it because it's really low contrast. This is plus, minus, multiplication, division. In other words, you do calculations using these operators. This is pick random 1 to 10, but you can control the range of a random number. Why would you want a random number generator in a game? Yeah, to make it more interesting. So the game setting can change on its own. This is less than, equal to, and greater than. You can compare values. This is and, this is or, this is not. In other words, you can combine comparisons and other things to make the logic more complicated. You can join hello and world to give you hello world. In other words, give it two components, it will string them together. It's really good for printing messages on the screen because now you can have portions of the message controlled by what we call variables. We'll talk about that later. And portions of it is just literal. You can make it look at individual letters of a word or sentence. In other words, you can make it process text one letter or one punctuation at a time. That can come in handy if you want to write a hangman game. Okay? How many people think it's somewhat trivial to write a game like Hangman? I'm making certain assumptions here, cultural assumptions. Does everybody understand what is the Hangman game?
Yeah.
Okay, so when you play the Hangman game with somebody else, you would think, oh, that's a pretty easy thing to do. But when it's time to write the logic so that the program can do it, it's not really quite that simple. Yep.
I tried doing a Pong game, and I got it to bounce off the paddles and everything. I just couldn't, I don't know how to get it to move, more than just a straight line.
Oh,
I couldn't
that's
get it
easy.
to do it.
You make it turn. You randomize the angle a little bit.
Oh.
It can also reflect, when you bounce against the wall, you can make the character, there's one thing in motion that makes it reflect and just go back in the other direction.
Yeah, I was able to make it reflect, but I wasn't trying to do the turning thing. So
Okay.
randomize it.
Yeah, you can just randomize it a little bit because that's how the Pong game was. You just randomize it a little bit. This is mod. Mod is easy. Mod basically is the remainder of a division, because when we use division, most of the time we take the quotient out of the division. Mod takes the remainder of a division, which is handy for certain things. This is round, which means you're rounding up and rounding down. You give it a fractional number, it will turn it into an integer. And this is square root, and it has all kinds of functions too. It has functions like absolute value, square root, sine, cosine, tangent, arcsine, arc cosine, arctangent, log, natural log, log 10, e to the power of something, and 10 to the power of something. In other words, for those of you who are taking a physics class and you're studying the effect of gravity, acceleration, and deceleration, this is a cool little tool that will help you, explain those concepts to somebody else. Because it has all the math functions to plot something, the trajectory of a projectile, okay, a rocket ship, okay, and stuff like that. I probably won't be using this to calculate the proper re-entry angle of a space vehicle, but it's capable of doing a lot of really interesting things. And then this part here is also kind of strange. Variables. What is a variable? We'll talk about a variable later. Okay. Do we have any questions about these tabs? The basic things that a sprite can do. Okay. No questions. This is all good. Let's make the sprite draw a square. Okay. We'll do it manually first, and then we'll have this thing automated. So before we do everything, we have to reset this whole thing. And there's a way to reset it. I just remember how to
Top
do
and
it.
middle, next to the sprite. In the middle there.
Randomize the turning.
The middle menu next to the sprite.
The middle menu. I'm sorry.
With the scripts, costume, and sounds tab, the middle menu.
I'm not just sorry.
It should be right next to the
Yep, so
sprite.
Here.
Yeah, it should be next to it.
It'll stop.
I think it's a little circle, half circle with the arrow.
Oh, okay, I see.
Got it.
I'm guessing at least.
Can't
normally.
rotate. Nope, that's not it. Don't rotate.
File, new.
How about the file root?
It's the only thing.
File new. Oh yeah, that would reset everything. There's a way to reset it. I just have to. Okay, I know how to reset the location because you can make it go back to 0, 0, and that's a motion thing. Go to X, Y. We just make it go to X 0, Y 0 again. But we also have to erase the stage. We go to stage. Now this is the other part that's interesting. The stage, which is quote unquote the background of this whole thing, is not static. It is actually active. It has its own scripting. Okay, which makes it kind of interesting because now you can add logic to the stage to interact with the character or the sprite. So with the stage, I think that's one easy way to reset everything. If you go to looks, there's a way to reset everything. Clear graphics effect. No, that's not it. And clear. There we go. Okay. So now we have everything starting from scratch again. And we can switch back to the sprite because we want to control the sprite to draw a square. How would you draw a square? Let's say I don't need a square to be rotated, I just want the square to be a certain size. Let's say 100 by 100 is the size of the square that I want to draw. How would you do it? Make it move 100 pixels, and then what?
Turn.
Make a 90-degree turn, and then move another 100 degree, and then turn again. So let's go ahead and do that. Okay, we'll go to pen first. Make sure the pen is down, and we also want to control the color. Just pick a color that's obvious on the screen here, and then we go back to motion. Make it move 100 steps. Okay, 100. Click the move button, so it does move 100 steps forward, leaving behind 100 pixels of blue pixels. And then we make it turn, so we want to make it turn 90 degrees. So you can go here and make it rotate 90 degrees, just like that. Click the button, so it actually does the rotation. And then we go back to move 100 steps again, turn again, move 100 steps again, and then turn again, and move another 100 steps, and we're done. Now if you want the square to look more obvious, you can go to looks, and hide the sprite itself, leaving only behind the square that it drew. That's pretty easy. Okay, but can we automate it? Can we make it so that we can just click one button and this is all done automatically?
Yeah.
Let's go ahead and try that. Okay. Yep, go ahead.
Are you able to control where the pen is on the sprite?
The sprite has a center, so there's a center pixel of the sprite, and the pen is always dropped over there. So you can control where the center of the sprite is, but that's not programmable. You can move the costume. You can change to a different costume if you want to leave a trail at different portions of the sprite. So you can kind of control that, but not directly control where the pen is located. It's always the dead center of the sprite itself. All right. So the next thing we'll do is to say, can we automate it? Because I don't want to have to click so many buttons every time I want to draw a square. I just want to click one thing, and I want a square drawn. So here's what we are going to do next is to quote unquote automate this. Now, this is not too bad. This is not too hard to automate. The first thing is we'll show the sprite again so that we can actually do some control here. And then we'll be using this area because we'll be writing a script to do it. Now, this is going to be a fairly straightforward script. The script will go to control here because I want to specify when do we start this action, okay? And I can say, in this case, there are 3 ways to start the script. I can say when the green flag is clicked, the green flag is this one here. Now the green flag is really is interesting because it applies to everything. All the sprites as well as the stage can be synchronized and say start the scripts when the green flag is clicked. So this is one global way to start everything going. I can also specify when a particular key is pressed, and I can choose any one of these keys plus more. So if I click, oh okay, I guess that's all the keys that I can use to specify when to start the script, or I can just say when this particular sprite is clicked. Did you guys see what I just did to specify the program? I just dragged and dropped a block, and we have the first step of the script. The first thing I might want to do is to clear the stage, but I can't really clear the stage using the sprite itself. So I can just go ahead and start with the rest. I go to motion. I want the sprite to point in the right direction, and this is the next step. I want it to point in the direction of 90 degrees. Next, I want to go to the pen portion and specify I want the pen to be down so that it will leave behind the trace. And then we can specify the things that we talked about earlier. First thing is to move 10 steps or 100 steps in this case, just like that. And then make it turn 90 degrees. So I have to change the angle like that, 90 degrees. And I can duplicate this block here and reattach the duplicate, and then I can duplicate it one more time. But you can see the power of exponent, right? I started off with one set of motion, I double it, I get 2, I double that again, I get 8 already. Because I get 4, I can double this one more time and I can get 8. Duplicate one more time. Oh, it's not duplicating everything, it's only duplicating a portion of it. When you want to toss something away, you just have to drag it back to this portion and it disappears. So I want to look at this whole thing, say duplicate. Now we have 8 sets of these actions. Attach it here. And you also want to specify where's the end of the program. The end of the program is just stop script. Technically speaking, you don't need it like this way, but it's better to do it this way, just so that we have a beginning and an end. Have you guys noticed that some blocks have certain notches and some blocks do not have certain types of notches and tabs? And that's because when you are starting, there's nothing before the start action, and that's why there's no notch here to connect it to another block. When you're at the end of a script, there's nothing after that. So there's no little tab to attach to the next block. But everything in between has both a notch, so they can specify what goes before that, and also a tab to specify what goes after that. In other words, instead of learning syntax, all you have to do is to look at this visually, and it makes sense. It makes programming a whole lot easier because you don't have to learn the syntax, or should I use a semicolon here? Should I use a period here? Should I use a comma here? There's no such thing in Scratch programming. Are we doing okay so far with this? Okay. So the next thing we'll do is to give this program a test. And to test the program, I probably want to reset the stage itself. So I go to the stage, click on the stage here. And with the stage, I might want to do some things to make it easier to reset the stage. So I'll do the same thing here. When the stage itself is clicked, I would go to, I think it is pen, exactly, clear, and that would be the end of what I need to do when I click the stage. I just wanted to reset itself. So stop script, click here, and now we are ready to run the program. I click the stage, and it's cleared. I click the sprite, and it drew the rectangle just really, really quickly that we could not see what happened in between. Are we doing okay so far with the program? What if I wanted to draw a bigger or a smaller square? I can change the numbers, right? But it's really tedious, isn't it? Because I have 4 places where 100 is specified. You can see, if I go back to the sprite here, this program has 100 steps specified here, 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 Actually, I think I specified 2 many times
Yeah, just
already.
need 4, right?
I only need 4. So we got 1, 2, 3, 4. The rest we don't need. We just toss it away. Put the script back here. End of the script back there, and we're done. Are we doing okay so far with the concept of this script? Okay. But as I said, I want to change the size of the square. But it's really cumbersome because if I want to change it to, like, let's say 75, I have to go here, change this to 75, change this to 75, change this one, and then change this one. And the next time, if I want to change the size again, I have to change 4 places again. So instead of doing this, I'm going to use a variable. Okay, so I'm starting to use the concept of a variable. I go to the variable tab, and I say, I'm going to make 1 variable. And I can name the variable. When I name this variable, I can name it so that I can also control who gets to see this particular variable. Let's just say that this variable is not going to be applicable to anything else, so I can click for this sprite only, and then I can say this is the length of a square. I'll just use the length here. Click OK, and now as soon as I click OK, many items appeared inside variable, because this is what you can do with a variable. The first one here allows you to specify whether it is visible up here. This makes it easier to debug a program because you can see the value of your variable all the time. You can also have this statement here to set the length variable to a particular value. Because it starts off with a value of 0, you may not want to draw a square of 0 length, right? So you might want to change it to something else. So I'll just kind of stick this at the beginning of the program so that I have one statement to change the length. And over here, every time I say 100, I don't want to use the constant 100 anymore. Instead, I want to specify strength. So can anyone imagine what I have to do to change 100 to refer to length as a variable? Drag and drop, right? Drag, drop, drag, drop, drag, drop, drag and drop. So now the program is no longer fixed to make squares that are 100 units wide. Now it is determined by the value of length. Okay. If I want this program to have the same effect as last time, I just have to change this 0 to 100, clear the stage, clear, and then click the sprite. And now it's doing the same thing as before. Now this is something that you should do when you write your program, is make smaller changes, test your program, make sure that your program is still doing what it is supposed to before you add any more logic to it. Any more logic to it. So this time I wanted to draw something else, maybe a smaller square, let's say 50 pixels wide. Clear the stage, click the sprite, and now it drew a smaller square. But this is still really cumbersome because every single time I run this script, I have to go in and change the program itself to change the size of the square that I'm drawing. Do you think I can make this program more interactive so that the sprite scratch can ask me how big of a rectangle, a square I want to draw? So instead of having to go change the program every single time, it would just ask me, and I just type in 150, 75, then it will draw a square of that size. Do you think that's possible? Okay, which mechanism we have talked about that might allow you to do something like that? Under which tab? We got motion, looks, sound, pen, control, sensing, operators. Let's look into sensing. Which one of these do you think will allow you to do that?
First you have to ask.
First, you have to ask. Very good. Okay, so before you change anything, you want to ask first. Okay, so instead of asking what's your name, we'll be asking size, square size. Okay, and then what do we do? Now, the next step is not really that obvious. We want the answer to this question to be the length. So what we do is we drag answer. Now, I'm not sure whether you guys can see it, but answer has a round,
Yeah.
it's a rounded, kind of edge. When you look at the variables, it also has a round edge like this. So that means when you go to sensing, everywhere you can specify a variable, you can also specify answer. So I can drag answer into here. So I'm setting the variable length to whatever the answer was when you answer the question square size. Okay, so let's go ahead and run this program again. I'm making very small changes every single time and then rerun the program just to make sure that it works the way it's supposed to. So now it's prompting me and ask me, okay, what is the square size? I should have made the prompt a little bit more self-explanatory, but this is good enough. Then I can specify, let's say 45, and then click the check button, and now it draws a little square, 45 pixels wide and 45 pixels tall. Do we have any questions about writing a script like this? Yep.
Can you adjust the speed the little
Yeah.
guy moves at?
You can adjust the speed, and you can even emulate, the walking if you want it to be, more interesting. Okay. But there's one thing I can also simplify here. Do you guys see any type of repetition? Yep, go ahead.
Can you put like two different lengths?
Two different lengths. The length variable can only store one single value at any particular time. So if you want to store two different lengths at the same time, you need two variables, because each variable can only store one single value. Okay. Are we doing okay so far?
Can you show me how to do that?
You just make a new variable,
And then okay.
and then you use another statement to store a value in there.
Alright.
Because I'm thinking, okay, you're thinking about a rectangle, right?
Yeah.
Yeah, so if you want to draw a rectangle or anything that doesn't have equal length, you need two variables to specify, what is the width and what is the height.
Okay.
Yep. Good question. But when you look at this program, do you see any type of steps that are repeated over time? There's some repeated steps here. Every time you write a program or a script and you see a lot of stuff that is repeating, you have to ask yourself, is there a better way to do it? Because repetition means, if you want to make changes, you have to make changes several times, and that's not necessarily, the easiest way to do things. So what I'll do is I'm going to take a look at this block here, and I say, that's a lot of repetition. In fact, there are exactly 4, repetitions of one, of two things. Okay. In other words, I'm taking this block here and I'm just repeating that 4 times. So, is there a better way to do it? You go to Control, and then you look through this list here. I know you have to scroll down, but you already got it. Yep. Repeat the number of times. So if you look at this little tab here, it says repeat 10 times, whatever is specified inside. So I'm going to drag this into here. And instead of repeating 10 times, I'm going to specify 4 times because I just want to draw a square. And then I drag this block of code so that it is inside the repeat block. This is useless at this point, so I'm just going to drag this part out and then specify the end here. So I'm making my program a little bit better because it is no longer, repeating the steps. It's not, just copying and pasting the steps a few times. This also sets it up to draw polygons later on, because right now it's only good for squares. But later on, I can make it draw any type of polygon, like triangles, pentagon, hexagon, and so on. So I'm going to gradually make this program do more and more and more. Are there any questions at this point about this program? Let me just double check the recording, because I think this recording is going to be quite useful.
Jack, you say that you can make the character actually move.
Yes,
You gotta use
but you
this
have to.
flash drive.
We'll fix that, because you have to specify another loop inside here so that it walks the right number of pixels, and then you have to control a delay between each step and then change costume along the way. So it makes the program a little bit more complicated. So right now I just want to focus on the number of steps, or number of sides of the polygon. Are we doing okay so far? Okay. But I want to test the program first because the program should still be doing exactly the same thing, except the logic, how I specify the action, is now a little bit more compact and a little bit more elegant. So I click the sprite, it asks me what is the size of the square. I specify, let's say this time I want to draw a bigger square. Click OK, and it drew a bigger square. That's all good. So remember one thing, when you develop software, you should really be testing the software along the way. Do not make a lot of changes to your program before you test it again, because if you make changes to 200 lines of your program and you test again and it doesn't work the way it's supposed to, then you have a lot of question marks. Which change that I made broke the program? If you make only 2 changes to the program and then you test it again, and the behavior changed and it's not working anymore, you only have to think back, okay, what changes did I make to the program? Oh, there were only 2 steps. Has to be one of these 2. It makes it a lot easier to pinpoint problems. A lot of people think, doing testing frequently like that is wasting time because, this is an easy change. I know exactly what it's supposed to do. My program should be fine. And the problem is, a lot of times, simple little changes are the ones that can cause the most problem. Okay, it's just like with repairing cars. A lot of times, costly repairs or what people think are costly repair are simple problems. I know I'm digressing, but I have time to digress. I used to have a Ford Escort. Okay, it's a '94 Ford Escort. Yeah, that's it. Has a little 4-cylinder engine in it, and one day it was idling really rough, and it's the power is lacking. So I'm not a car person. I don't know how to repair cars. So I sent it to a shop. The guy at the shop, I know he's really honest because he had done many other types of repair jobs before. So I just drop off the car. It's idling rough, and it doesn't have the power. And then 2 days later, I tried to pick up the car, and the guy said he still could not find what the problem was. Okay, and then later on, so I took the car back. He didn't charge a single penny. He's really honest. Later on, can anyone guess what the problem was?
Convert.
Most people think it's something serious, right? It's idling rough, and it's the power is dropping. It turned out to be. Go ahead.
The battery.
Nope, it's not the battery.
Oh, there was no buildup on the battery for it.
Nope. You're close.
Is it the radio?
Hmm?
What was the problem with the car?
The problem was it was idling rough, and the power is not there. The Ford Escort only had 88 horses to begin with, and it was down to something way less than that. It turned out to be a faulty spark plug cable. That was it. Okay. Yep. Because if the spark cannot be delivered to the combustion chamber, to the spark plug, then that cylinder is quote unquote dead. It's not doing any work. But it's actually still siphoning power because the compression cycle is still compressing the air, inside the cylinder. So it's actually, taxing the power from the other cylinders when it's not working itself.
It's working harder.
Everybody else has to work a little harder, and it's all just wasted energy to heat up the gas inside that cylinder and then expel it later on. Okay, and it was as simple as that. Okay, and this really connects back to programming because a lot of times big problems, or what we think is a serious problem with a program, really starts off with simple stuff. Okay, you're missing by 1. Are you getting out of a loop too early? 1 time too early, 1 iteration too early. That can lead to as many problems as the more serious logic problems. Okay, so now we got this problem fixed. Do you think we can change this program to draw just polygons in general instead of squares? Let's go ahead and give it a try. Okay, what do you think we need to do first to draw polygons instead of squares? What is do? Let's look at. Ask another question, and then we need something else to store the answer of the other question. Another variable, very good. So we'll start with another variable because now we need to store something else. Make another variable. What do you think this variable will be storing? number of sides. Okay, so we'll just say num sides here. And it's only usable for this particular sprite, so we will just create it this way. Any questions at this point? We have to go back to the script here, because now it has to ask a second question. The second question, now this time we have to be careful where to put this question, because we don't want to put this question before set length and after ask square size. We have to put this right after set length, so that the answer is no longer useful for this purpose, for the original purpose. So we'll just ask, what is the number of size and weight? And then we go back to variables, and then we say, set, but this time not length anymore. We want to set number of size to the answer. I double clicked. When you double click, it starts the execution too. Stop. So now we have to drag num size to, oops, I did the wrong thing, sorry. I have to drag the answer. So it is now remembering the answer to that question. What is the number of size to the variable called num size? And then num size is an extra thing here. It really has nowhere to go. So now I have a separate question and a separate variable to remember the number of sides. But the rest of the program is not making use of this variable yet. How should I use num size in this program?
In the repeat.
In the repeat, okay. So over here, instead of repeating exactly 4 times, I should be repeating the number of size which is stored in the variable. So we'll stick it here. Do you see how easy it is to specify a variable instead of a constant? You just drag a variable into a space where a constant goes. But we also have to make one more change, which is how much to turn when it is time to make a turn. How should we determine that?
Divided by number of sides.
360 divided by the number of sides. Very good. Now this part is a little bit less intuitive, because when we think about 360, so we want to type 360 right away. But in this program, you have to think about the operators. What is the last operator you need to perform before you get the result? The last operator is the division operator. So now you have to stick the division operator first, and then you specify in the first number, or I kept double clicking it. You have to specify this is the dividend of a division. It is 360. And we want 360 to be divided by number of sides. So we stick that over here. And you can see that I only have to type when I need to specify constants, and also the sentences or the prompt. But for everything else, it's all drag and drop. It's virtually impossible to make syntax mistakes or grammar mistakes in this case. Okay, it's really somewhat foolproof. So we want to test this program now. Clear the stage. Come on. Click sprite. Click the sprite. Oh, click the sprite once. It asks me. Oh, that's the wrong question, but we'll just let it slip for now. Let's say 45. Click it. It will ask me the number of sides. Let's try a triangle. Okay. So a triangle has exactly 3 sides. Click it, and it drew a triangle. We can try a hexagon. It can only work well with numbers that divide 360. So if you try to specify, let's say 11 sides, it's not going to work very well. It might work well in that case too. Let's try 11 sides. We have to make it smaller, because when you have 11 sides and you specify a large length, it will be because the more size you specify, the closer it gets to a circle. But each side, each segment, will be the length that you specify. So when we specify more size, we have to decrease the length of one side. So in this case, let's make it, let's say 20. And it has 11 sides. I forgot to click the backstage, and that's why it didn't clear the triangle.
Click 0 sides, will it draw a circle?
It will do a division by 0, and it will be a problem.
That is illogical.
Because when you specify 0, then it will be, oh, actually, it will get out of the loop right here because repeating 0 times means it's not going to do anything inside the loop. Very good. Good thinking there.
But if you do 360 sides, that'd be the circle, right?
There'll be a circle, yep.
For the
Well,
most part, technically.
it's not a circle, it is still a polygon with 360 sides.
Yeah.
So if you
It
make
just
the,
seems like it.
yep, it will be a good approximation of a circle. Are we doing okay so far? Are we having fun yet with this? Okay. Let's say that I want to do some error checking before I let it go forward because I want to make sure that the number of sides is not 0. Let's say that's what I want to do. Okay, I want to do some error checking. Error checking is a big deal because most of the code of any program that has a user interface, about 50% of the code has to do with error checking, which I think is amazing. Okay, if you think about it, what that means is if you assume an end user will always input valid, correct data, your program, most programs will be shrunk in half. Okay, so a lot of code is really just specify the logic and say, okay, I know end users can make all sorts of mistakes. Okay, let's check all of these mistakes and prompt the user again if a particular problem happens. So what do I need to do here? First of all, if I want to fix the mistake of not letting someone to enter a negative number or 0 as the number of sides, do you think these steps will be repeated, potentially be repeated over and over again? Because an end user can keep putting in invalid values, right? So it becomes a loop, potentially a loop, because we can be repeating the same step over and over again. Well, if we know that this can be potentially a loop or have a way to go back to wherever it is before, we can actually use the icons here to understand which one may be applicable. Forever, which is the second one from the top, let me just point out which one. This one here is probably not something that we want to use because forever means forever. Okay, you will be asking those questions forever. That's not very good. Okay, because it will be very annoying to the end user. Repeating a certain number of times is not going to work because we don't know how many times or how many tries it will take for an end user to specify the correct logic. So that's not going to work either. Forever if, okay, that's not going to work because we can see that it has no tab to connect to the next action. But we do have some other actions to perform after we ask the number of sides. So that's not going to work either. You go down a little bit more. Every time you see this little up arrow here, you may not be able to see this is an up arrow. That means it's a loop. You can go back to an earlier step. This is the last one, our last best hope, right? It's repeat until. Hey, that seems to fit the bill because it says, we are only going to go back again and again, but we'll stop, when a certain condition is satisfied. So we'll try this one. We'll use repeat until and stick it here. And then we know that we have to prompt the question again and set the variable again. The question is, what do we put here? When do we get out from this loop? In other words, when do we stop, asking this question and having the end user to type in the answer again and again?
Why do we have to do the loop for this?
Sorry?
Why do we have to do the loop for this? Why do we have to give us cancellation?
Because the end user may input a negative number all the time or a 0 all the time. So we have to wait until the answer is no longer. Go ahead.
Can you draw more than one shape at the same time?
More than one shape at the same time.
Like, does it like circle and a square?
It can only do, the sprite can only do one thing. One sprite can only do one thing at a time. So you have to do it sequentially. If you want to draw a square and a circle, or and a triangle, you have to draw one shape at a time.
Just like how it looks like that.
Well, this is because I forgot to erase it. I forgot to click the background to erase it. Okay, so let's see what we can do here. How about repeating? I know that this condition here has something to do with the number of sides, right?
Number size greater than 0.
Yep.
You just put greater than 0.
Greater than 0. So we have to specify an operator first because comparison is an operator. and then we just stick this here, and then specify 0 on this side, and then specify the variable called num size on the other side, and then we can put everything else back here and test the code. Square size, okay, let's say 20. Oh, I forgot. Oh, do you know what the problem was? It's checking the condition before asking the question. It already had a value of 11, and that's why it never asked the question. So that means we have to do something like this. We have to duplicate it so that, stop. Right click, duplicate. You have to duplicate the whole block. When you want to duplicate the entire block, you have to right click at the top part of the block. So we duplicate it, put it here, and then put it here. That's how we can specify this. So we'll go ahead and start the program again by clicking this right. Okay, 30 as the width, as the length of one side. And then the number of sides, now let's try something unreasonable, -2. Ah, doesn't like it, it asked me the question again. But it didn't give me an error message, okay? It just kept asking the same question, yep.
When you do it more than 2 sides though,
Yeah, 2 will give you a line, 1 will give you a line 2.
so what do you have to do good?
Greater than 2, yeah, that makes more sense. But anyway, the program has one flaw now because even though it goes into a loop, it didn't give me an error message. It didn't tell me what's wrong with my previous answer. So maybe we should do something about that too. So we'll go ahead and change this to greater than 1 because 2 is the minimum. Or if you want it to be an actual polygon, you want it to be at least 3. So greater than 2 is what we want. But we also wanted to print an error message. In other words, if the end user inputs a number that is incorrect, something that's not reasonable, we want the program to give to print out an error message and say, hey, the value that you specified is not correct, is not valid. So how are we going to do that?
Say a message.
But we don't want to say that message all the time because sometimes the user might have entered the correct value, a valid value. So we need something that will only do certain things sometimes but not all the time. And if a conditional statement. Very good. So what we'll do is to first fix a few things. Instead of square size, we'll just say, the length, what is the length of each side. And then what we want to do is I'm going to drag this out first so that we can specify the logic and then put it back in. So what we want to do is to go to control, and this time we want to look at something that will do something only if a certain condition is true. And this is the block that we have to use. It's called an if block or a conditional statement. The if block specifies that if the hexagon is true, then we'll go ahead and do whatever is specified in between. But if whatever is specified in the hexagon is not true or false, it will just skip the block and continue execution with whatever is next to it. It is not a loop. It does not repeat something. It's a one-shot evaluation. If this is true, go ahead and do this. If this is false, skip and do whatever is next. So what we want to do here is to specify the opposite of this logic here. So I'll just go ahead and specify the opposite here. So we'll stick the comparison here. So if the number of sides is less than 3, then we'll go ahead and print an error message. We'll just complain about it. Okay. And to complain about it, we have a few choices. We can go to looks. We can either say something or we can think something. We'll just go ahead and say. And we'll basically print an error message. Make sure the number of sides is at least 3. Okay. And now we can stick this entire block back into here. run the program again. Click the backstage to clear the screen. Click the sprite to start the program. What is the length of each side? I should probably have error checking for that too, but I'm not going to do that, right now. What is the number of sides? Let's try again. -2. And now it prints the message for 2 seconds. So it's doing some error checking. Let's specify a correct value. Click OK, and it does the drawing. In other words, I'm making the program a little bit more complicated each time to make the program more complete. Yep.
Okay, so it seems like this block if we don't really need it because we already.
That is correct.
Yeah.
It's not needed
We just
because
can say save, make sure the number we don't need it.
because otherwise we will not be in
Yeah, we're
the
not
loop
gonna
to
be in
begin
it.
with. That is correct. Yep. Does everybody get that? No? Okay. The comment was, this is not, the if is not needed. In other words, I could have simplified this by just, pulling the say out of it and forgetting the if, because how do we get into this loop to begin with? Number of size is not greater than 2. If the number of size is not greater than 2, we get into the loop, which means, we have to print the error message. Any other questions about this? Now somebody asked me about the animation effect, so we'll go ahead and do the animation effect. And this is also a good time to illustrate how you can use multiple sprites. Okay, so I'm going to start with a new sprite here. Paint a new sprite. You can also choose a new sprite from file. In other words, it has a lot of sprites already built into the program. When you install it, it's installed with all these different sprites. Within the programs, it has bats, or great for Halloween. It's got a cat like this, cat 3, cat 4, dogs, fish, grasshopper, and squirrel. I hate squirrels.
They always like to run in front of you.
Anyone with a garden or a backyard that has anything that's edible to squirrel will not like squirrels too much. I don't care so much about the acorns because I know acorns are edible because the indigenous people around here, the Maidus and many other tribes, actually use that as their grain. That's their source of food. But it's a lot of trouble. I don't have time to do it because you have to grind it to a powder, and then you have to wash it. It's a lot of trouble.
Not worth it.
I suppose I can use my food processor too.
Maybe you can even automate it.
Yep, stick it in the food processor, push a button. Maybe they will start to sell that at Whole Food for more than what they charge for the other types of whole grain stuff. I'm not a health food guy, so that's all new. I'm going to draw my own thing here. Okay, so what I'll do is I'm going to draw a spider. So when you draw something, you can start with these basic shapes, or you can import something from a picture. But I'm going to start with this, and I want this circle to be. So this is going to be the body of the spider. I'm going to make this really simple, and then you can specify a different color. So we'll specify some red eyes here. Okay, that's 1. That's 2. And then you can use either straight lines or freehand to draw the legs. Now, if you want to draw the legs, if you want to make it so that it looks like it's moving, then you have to draw the legs in a certain way. So we'll go ahead and go to the draw, which is a paintbrush. And I can use, a dark, let's say dark purple color for the legs. So now I can specify two are closer. And on this part, we have the 2 middle legs a little bit further apart. Okay, so that's my costume number 1. And now I can set the center. Now, since somebody asked, where is the pen? That's the center of the costume. So you can actually position it any way you want. In the case of a spider, you can leave it all the way to the end here because that's where the silk usually comes out of. So that's how you can specify the end. So you can specify the location. And that's it. I'm going to click OK here. And that's my sprite 2. Now with my sprite 2, this is my first costume. I can actually edit this or I can copy it. In other words, my second costume is based on the first costume, and I just have to make some changes to make the second costume so that it's an animated version of the first one. So the second one, I would just go ahead and flip the legs, upside down. These ones that are spread out, and no, undo.
My masterpiece.
Okay, so I'm gonna erase just certain portions of it. Go back to my pen tool, go back to the same color. And this time I'll make these ones go straight. And then make these go, it's not gonna look that good.
Yeah, but
You guys get the idea.
Yeah, that's not the rabbit.
Evil rabbit.
Evil rabbit.
Vampire rabbit.
with its eyes on one side.
And then we'll
Demented.
see where are these, that. Okay, that's good enough. All right, so now we have two sprites or two costumes for this sprite here. And what we want to do is, I'm going to forget about this one for now. And instead I'll just write the program or the script for the spider. So you can see now the program has two sprites. Each sprite gets its own script. Now that is cool because you can write one script that will tell the cat how the cat should move around, and you have another program to tell the spider how it should move around. And if you want to specify the logic, they can detect whether they're touching or not. So the spider can catch the cat and kill the cat, or vice versa.
Take a while, but that'd be an interesting thing to draw.
It won't take that long. Okay, but we want to try the animation effect here. So we'll go ahead and try it out. And the way to do it is to, I don't want to do everything by hand, so I'm going to use a loop to do it. So this time I'll go when the green flag is clicked. Maybe we'll just when sprite 2 is clicked. We'll go ahead and get into a loop because I want to repeat some steps, let's say 10 times. And each time in the step, I want to go to motion and just move a little bit. Okay, let's just say 10 steps at a time. And then we'll do a pause because otherwise it will just be like that and you cannot see the actual animation effect. So if you want to see the animation effect, you want to wait a little bit. And that goes to, I think, looks to, I cannot remember. It's under control. Wait 1 second. 1 second is really long, so we'll make it wait maybe 0.2 seconds, 200 milliseconds. And then we'll go to looks and change the costume. So we'll just go to next costume. Now this is really cool because as long as your costumes are designed in a cycle, in other words, the last one connects back to the first one, this is the best option because it will just go through the cycle of the costumes and make it look like it's an animated type of thing. And I think that's all that I need to specify. Maybe I should wait again, wait another 0.2 seconds, just for the effect to become more obvious. I can always change it later. So I can change the order, stick it back into the loop. Yep, go ahead.
Is there a way to change a sprite into another sprite?
No, because the sprite is it's a core concept of the whole thing. All the sprites are active at all the time. You can make a sprite hide itself, if that's what you want. You can make one sprite hide itself and make the other one unhide itself, so it would appear that you're going from one sprite to another sprite. Yep, go ahead. So I'm going to change this to 0.2 seconds to, and specify an end. Even though it's not really necessary, we'll go ahead and specify one end to this entire script. And then we click the spider. What is it doing?
2 steps forward, 1 step back.
Yeah. Oh, that's because I forgot to change the center, I think.
Yeah.
Okay, let's go back to the sprite costume design, go to the second one, And yep, it has a different center. So we have to make sure the center of the different costumes are the same at the same place. Okay. All right, let's try again.
There you
There you go. I know it's very crude, but it shows you the possibilities. Okay? So for those of you who want this to be fancy, what you do is you use a video camera and record a short script of an actual spider crawling. Okay? And then what you do is for, let's say you record a second, of a spider crawling. So what you do is you take samples of the frames, one at the beginning, one at 1/4 of a second, one at half a second, 3/4 of a second. So now you have 4 images of the spider crawling. I don't know how long one cycle is for the spider to finish one walk cycle, but you have to make sure that it finishes like one walk cycle. And then you just stick those pictures as the costume of a spider, and now you have a realistic animation of a spider walking or crawling in this case. Okay. Are there any questions? Now somebody's asked. Go ahead.
I was gonna wonder how you make a list pop up, appear and disappear.
A list?
Yeah, how you can make a list show up and disappear. To make a pause menu, just to pause it.
Just to pause it.
That way, if you hit the button, like a button P, it'll pop up, and if you press it again, it'll disappear.
Ah. Do you have to stop everything?
Well, for like a Pong game, just to keep the ball from moving. And once you press P again, it'll start going what it was doing before.
That may be a little bit difficult because you can specify multiple scripts for the same sprite. Okay. Now let me show you what I mean by that. Okay. This is also kind of interesting. I can make one just for the animation effect. In other words, this one does not move at all. Okay, I'm gonna take this away, and when I run the script, the spider is just doing its animation, but it's not moving. It's not going anywhere. So what I can do now is I can specify another script. Now this is really cool because it's concurrent programming, or you can write different programs that run at the same time. I can write another script that also starts when the sprite is clicked, and this one specifies a loop similar to this. So I'm going to duplicate this, stick the original back here, stick the modified version here, but it's not going to do anything with the costume. Instead, oh, I erased too much. Is there an undo here? No.
Control
Okay.
Z.
Hmm?
Control Z.
Control Z. I don't think it's gonna work here. Control Z doesn't work. That's all right. We'll just have to do it again.
Save it.
So the second one is not going to do any type of costume work. So I'm going to take only that part out, stick the weight back in. But the second one will just do the motion. All right. So now we have 2 scripts applicable to the same sprite. They will run at the same time. Each one controls a different aspect of that particular sprite. We'll go ahead and see what happens when we click the sprite. You can see that it walks and it changes its costume. Because both programs are actually running at the same time. It's just that the first one changes the costume. The second one changes, does the movement. So now you can imagine you can write another one that can ask questions or put a thought bubble up at the same time. The question is, when do you want to trigger that logic? That's the question. Okay? Are there any questions at this point? No questions? Now, I want to leave this to you guys. For those of you who are interested, it's not a homework assignment. It's just something for you guys to think about. When I design a program like this, well, first of all, okay, let's say by next Tuesday, I want you guys to kind of think about this, install Scratch, and think about how do I make the spider go back and forth. In other words, I want to make the spider so that it will walk all the way to this edge here. When it touches the end of this wall, it will turn around and walk backwards again. In other words, it's just walking back and forth like this.
You do a 180-degree turn to make it go back turn.
You have to sense that you are at the end too, so you have to detect, whether you're at the end. When you are, you have to turn around and then go the other way, and then when you touch the wall again,
Will
you
that
have
be
to
a
turn
control
around again.
movement, though?
Well, you have
Will that
the-
be a control movement?
You have to control the movement, but you also have to use sensing.
Which tab? You mean like this?
Yep, something like that.
And then once it reaches a certain spot,
Yep.
it'll keep
And there's a
going
way
back.
to
You have
detect
the-
it.
The
Yeah.
width of the screen. You have the X button.
Look at the touching.
Exactly.
The touching, has you can specify. Now this is sprite 2, which is the spider, so it can detect whether it's touching the mouse pointer, the edge, or sprite 1. So use this to help you determine when to turn around, because once you turn around, you can just keep walking again until it touches the other edge, and you can make this program an infinite loop. In other words, it just keeps going back and forth. Okay. So just use it as an introduction to programming, because we are basically shifting gear at this point. Instead of just talking about software and how to use Windows and Microsoft Office and so on and so forth, I think this is a lot more interesting. That's just my personal opinion. Okay, so today's lecture is actually recorded, so that means all the steps that I demonstrated. Yep, sign up sheet. Sorry, forgot about it. Do it now. Okay. And I can probably stop the recorder at this point.